Welcome to More An Hour Maths. I am your personal tutor, Mr. Daniel King, and today we are going over the chain rule. Right, so as you can see, the boxed equation on the red is the chain rule. dy by dx equals dy by du times du by dx. So what does that mean? Sounds a bit confusing, right? So I am going to go through what that means today. So if you look at the question, y equals 3x to the 4 plus x, all to the power of 5. You may receive something like this in your exam, or you might come across it. So what do? I mean, you can expand the brackets, but I mean, you'll be there for ages if you try to do the binomial expansion on that. I mean, it'd be ridiculous. So lucky for you, some genius fella, who I don't know the name of, invented the chain rule. So I'm going to go through this as an example. Let me get my pen out. There it is. So, first thing that you do when it comes to the chain rule. What you do is you set a variable. So, let's get a variable. Let's call it u. And what you want to do is you want to set this variable u to something else. So, in this case, what we're going to do is we're going to set it to 3x to the power of 4 plus x, okay? And essentially what you can do is you can rewrite this equation. So we can get y equals u to the power of 5. You see what I've done there? So you can differentiate u to the power of 5, right? That's just 5u to the power of 4. So we've got it in a much more manageable format. But it's not quite as simple as that. So, what you want to follow this equation. So I'm going to differentiate this y term. So if I do dy, now if I differentiate it, I'm differentiating it with respect to u. So it'll be dy by du. As you can see there, dy by du is a term in our equation, right? And we know if we differentiate that, I told you already, 5u to the power of 4. Once you look at that, guys. But take a look at this u term. It's interesting because we know u is equal to 3x to the 4 plus x. So, theoretically, dy by du is 5 in brackets 3x to the power of 4 plus x all raised to the power of 4. Great, that is our first term sorted out, right? But what about this next bit? See, in this equation for the chain rule, the next bit is du by dx. So what I'm going to do is if you differentiate u with respect to x, as you know from year 12 maths, you know how to differentiate polymers. So you times the power by the coefficient. So that'll be 4 times 3, which is 12. It'll be 12x cubed plus 1. Okay, so what about the next bit? So the chain rule asks us to multiply the dy by du and the du by dx together. But why? See, if you look at the chain rule up here, the dy by du, actually, you can cancel this out. If I go up here, if I were to write this together, I'll get dy times by du over du dx. But you see, I actually have this common du term that I can cross out. So we're actually left with dy by dx. So hopefully you can see why we've made this this u term. So let's get on with multiplying these terms together. So I'm just going to go down. Okay, so what do? We want to multiply these terms. Let's get 5 3x to the power of 4 plus x all to the power of 4. So that's our dy by du. Multiply it by du by dx, which is 12x cubed plus 1. Okay? And that is essentially our answer. Right? I'm just going to put it in a more sensible format. And this will give you dy by dx. That's essentially it, guys, for the chain rule. Right? But you can also use this for other things. So I'm just going to quickly erase all of this stuff using our magic rubber. You can also do this with trigonometry, as always. You'll see in A-level maths in future topics, trigonometry will always come up in calculus. It's everywhere, this poxy thing. So you can do this with sine and cos. So let's do y equals sine to the 4 x. So what can we do here? What's our substitution? What can we substitute u for? Well, we can make sine x equal to u. And if we were to rewrite this, we would get y equals u to the power of 4. Now, that's an easy substitution, easy differentiation. We know dy with respect to du, that's just 4u cubed. What about this? du by dx. So I'm assuming you know how to differentiate sine and cos. For those of you that are doing Edexcel maths, I don't know if this is true for other examples, but you do rules of differentiation after you've learned deriving sine, cos. So yeah, make sure you know how to do that before continuing watching this. So the derivative of sine is just cos x. There we go. And then using the equation dy by du, well, dy by du is 4u cubed, but but we know u is equal to sine x. Okay, so let's quickly make that substitution so we don't forget. There it is. So dy by dx is equal to dy by du. dy by du is 4 sine cubed x multiplied by du by dx, which is just simply it's just cos x. And I believe we are done. Nice. Okay, so moving on to the next question. So let's just rub all of that out. The next question, y is equal to cos 2x minus 1. Okay, so as our good friend Mr. Hegarty would say, pause the video, have a go. Okay, so I'm assuming that you're part of the 10% of people that paused the video and attempted this. So what would our substitution be, people? Well, we can set u is equal to 2, I don't know what that was all about. We can set u equal to 2x minus 1, okay? So if we were to rewrite this equation, we would get y is equal to cos u, okay? And as you know, let's first of all derive this. So we know dy by du. If we were to derive cos, that will be minus sine u. I think in a future video I'll probably go over why like sine is how sine is derived and how cos is derived and all of that. And let's go over to this u term. So we know du by dx would just simply be 2, guys. Okay, well, let's just quickly sort out this u bit here, because we know dy by du minus sine u is equal to 2x minus 1. So let's just quickly pop u in there. And essentially what we can do is multiply these together. So dy by dx is equal to dy by du, which is minus sine 2x minus 1 multiplied by 2. So that will become, just get rid of that, minus 2 sine 2x minus 1. Okay, I think you've got the hang of this. So let's step this up a gear. Let's remove that notification. Guys, for the final question, this is a tricky question. This one is very, very challenging. So I'm not expecting you to get this, but if you do, well done. It is y equals to the square root of sin root x. How do we go about doing this? Right, well, first thing that we can do is we can maybe try and think of a substitution. Well, we've got u. What can we set u equal to? Maybe root x? Root x should work. Okay, well, let's try and get y in terms of u. Okay, so y in terms of u would be root sine u. Okay, well, that simplifies things a bit, but we still don't know how to differentiate this root sine u. This is where things get hard, guys. So essentially with this question, you have to do a chain rule within a chain rule, because the only way to integrate root sine u is to do a chain rule. But let's go to the u term. Okay, so let's quickly differentiate that, because we know the sine rule is dy by du multiplied by du by dx, right? We can easily get this du by dx term. Okay, that's easy. That's easy. So essentially, what root x is x to the power of a half. That would give us a half x to the power of minus a half. Another way of writing half x to the power of a half would be 1 over 2 root x. Excuse my bad handwriting. So that gives us our du by dx, okay? Hopefully that should give you a couple marks on the exam already. But what about dy by du? This is what we're trying to find, dy by du. Okay, now this is where things get interesting. So what can we do? We can do another chain rule, as I mentioned. So let's make a completely new variable, right? We've got y, we've got x, we've got u. It is time for w. This is already turning into the Avengers Endgame of maths questions. I can assure you they do get a lot worse than this. Okay, so w we can set to sine u. Okay. And what we can do is we can go ahead and differentiate this equation. I will explain why in a minute, but bear with me. Okay, so cos u. Alright, that's alright, that's simple enough. Another thing that we can do, we've got w is equal to sine u. Okay, so we can rewrite the y equation. Y is essentially equal to square root of w. Okay, and let's derive this equation. Dy by dw. We did this one before. It's essentially 1 over 2 root w. We did it in this one up here. Okay, I will now explain why I've done that. Now, we are trying to find dy by du. Okay, so dy by du. Another way of writing this is dy by dw times dw by du. Because can you see here? The w's, they cancel out. And we will be left with dy by du. And that's exactly why I've done what I've did. Okay, so now what? Well, before we start multiplying these terms together, let's just quickly tidy up dy by dw. Okay, another way of writing that is 1 over 2 root, And we know what W is. W is equal to this. Sine U. Okay, now let's put all of this together. So we know dy by dw is 1 over 2 root sine u multiplied by dw by du. That's just cos u. And look what we've got here. Go away, notifications. You're embarrassing me. So, tidying that up even more, we know for a fact. Here we go, guys. dy by du is equal to cos u over 2 root sine u. Okay. So, we've got dy by du. Okay, this here is dy by du. We also have du by dx, okay? Now we can start using the chain rule. The chain rule tells us dy by dx is equal to dy by du. So dy by du is this equation here, okay? And essentially what we're going to do is multiply that by this equation, the du by dx. All right, that's all we're going to do. But before I do all that, we've got this u to deal with. But we know for a fact, where is it? Where's u? Hello, u. U is equal to root x. So why not we just substitute u for root x? Cos root x over 2 sine, 2 root sine root x, okay? So that's our dy by du. That is it in its fully solved form. But we need to multiply it by 1 over 2 root x. Okay, so 1 over 2 root x was equal to du by dx. Du by dx, okay? So we know that from what we've already done. Okay, so let's put this all together. So dy by dx is equal to dy by du. Okay, so that's cos root x over 2 root sine root x multiplied by du by dx, which is 1 over 2 root x. And now we've got to play the game of tidying up the maths question. Okay? So, if we were to tidy this up, the numerator is easy, cos root x, nice and easy. We know how to multiply fractions, we just multiply the denominator, and also the numerator, which we've just done. So, if we were to multiply the denominator, what we've got is, we've got the 2's, so 2 times 2 is 4, nice and easy. But then the next bit is interesting, guys, look at this. So we've got root sine root x, okay? And then we've got this root x as well to deal with. And we're still not done yet, so thank you, Canva. We can also simplify it. Okay, so we've got cos root x on the top, which is no longer a problem for us. On the denominator, 4, yeah. Now, can you see here, this term, the x, and the sine root x, they both share a square root. So, essentially, we can do this. X sine root x. Okay, and that is the answer to this horrible, horrible maths question. So, as I said, I'm not expecting you to get it right. But if you want to challenge yourself, it's there. Well done if you got that right. That'll be about 5 marks on the exam. So good job. And look at that, guys. Isn't that just beautiful? So that's it for today's video, guys. If you found this video informative, please like and subscribe. And I will catch you in the next one. Peace out.